The race is well and truly on to discover life in faraway worlds. Between the SETI program and NASA's Kepler and K2 missions, we've never been closer to confirming that we're not alone. Some researchers believe that we are likely to discover alien life within the next 20 years. But what will it look like? Thanks to science fiction shows, we often think of the standard gray alien. But with such a variety of planets out there, life could look very, very different to our own bipedal expectations. It's time to get your tinfoil hats out as we find out what scientists predict aliens on other planets will look like. Number 10. Planets like ours. In 2013, researchers working on the Kepler mission reported that, based on initial data, there could be as many as 40 billion planets the same size as Earth in the Milky Way, of which 11 billion orbit stars similar to our own Sun. Whilst several more nuanced factors are needed to harbor life, it still means there's a very good chance that life exists on planets similar to our own. The nearest star system to us, Proxima Centauri, even has at least one planet that's potentially in the habitable zone where life could survive. But what will life look like on a planet like this? One theory of convergent evolution suggests that animals who experience similar environments will develop similar solutions to the problems that they face. Basically, alien life developing on a planet similar to ours may actually be quite like us. Animal and plant life will likely be quite familiar on these worlds, and even human-like life can exist. Think bipedal humanoid creatures like the ones portrayed in Hollywood movies. But according to Harvard biologist Jonathan Losos, this isn't inevitable, because there are multiple ways different animals adapt to the same environmental circumstance. For example, woodpeckers and aye-ayes developed different evolutionary solutions on Earth for feeding on grubs and trees. Whilst woodpeckers use their beaks and then tongue to chisel out and grab grubs, aye-ayes filled the same niche on isolated islands where woodpeckers don't inhabit. Aye-ayes have a long third finger that allows them to locate and snag larvae. They essentially do the same thing, but adapted differently to fill the same niche. So life on other planets may not be our doppelgangers. They could have evolved wings instead of legs, or some bizarre alternative features we could never imagine. Number 9. Low-gravity planets. Mars is the most likely planet in our solar system to harbor life, but it still sits on the edge of the habitable zone. It's a hostile environment, which experiences massive fluctuation in temperatures, with almost no oxygen or atmosphere, which makes it almost impossible for normal life forms to survive there. Even so, it turns out there's something on our own planet that can withstand these conditions. There's a methane-producing microorganism that lives in the guts of cows that could easily survive on Mars. It's very possible similar organisms are present on the red planet, since levels of methane have been discovered on it. But if larger life forms do exist on planets similar to Mars, a big factor influencing their evolution would be its low gravity. Larger animals on low-gravity planets would look very different from those on Earth. There would be a smaller need for muscle mass or bone strength, so be prepared to encounter species with long, spindly legs, or potentially very tall versions of the greys. They need less energy, less heat, less heart, and less blood, so all organs involved in the management of those processes would be less developed than they need to be on Earth. The maximum height of life is inversely related to gravity, so on a planet with half the gravity of ours, we can expect any human-like creatures to be up to twice our height. Number 8. Super-Earths. The vast majority of planets that have been discovered so far are super-Earths, ones that are between 1.2 and 5 times the size of our own. Their larger mass usually leads to a greater gravitational pull, which will have an overriding impact on how life evolves there. As a result, complex life forms are likely to be shorter and stockier than they are here, something that will lower the amount of injuries caused by a fall, and give them more stability given the higher gravitational acceleration. It's even thought that bipedal life may not develop at all on these planets, because of the danger involved in being high off the ground. These much higher pressures exerted on the body means that their makeup is likely to be very different too. Bone joints, for example, will be put under much greater pressure, so it's likely they'd have more muscle-built structures than skeletal ones like we see on our planet. It would also take much more energy to pump blood around the circulatory system, so animals on these planets will likely have very large hearts. Small and functional will rule the roost here. Number 7. Hot planets. If the assumption is that life on other planets is carbon-based, then they're limited to temperatures between 32 and 212 degrees Fahrenheit, because this is the temperature range in which water is a liquid. Our planet, at an average temperature of 41 degrees Fahrenheit, is surprisingly cold, and means that carbon-based life forms could evolve on planets much hotter than our own. Life forms in much hotter climates would need traits to help them cope with this heat, though. They may develop things like highly reflective skin, a low absorbance exoskeleton, or maybe even a secondary circulatory system designed to bring heat to the surface. Number 6. In a star. Stars are the hottest known places in the universe and exhibit temperatures that we can't even conceive living within. Our own sun, for example, is 9,900 degrees Fahrenheit on its surface and a whopping 17 million degrees Fahrenheit at some points of its atmosphere. This heat would instantly incinerate organic life as we know it, but there's nothing to say that life like ours is the only kind that exists. The idea of energy-based life forms has been discussed for a long time. Chemistry on Earth sees the nuclei of cells being surrounded by electrons, but it's possible that, as an alternative, the chemistry that led to life relied on nuclear reactions. The mass comes from the strong force of the nuclei, and not the electromagnetic forces of the electrons. Nuclear molecules have actually been created on Earth, but only stayed in existence for very short times. If in the extreme heat and pressure of a star, these become more viable though, and they could form the basis of a theoretical life form that is composed of energy rather than matter, which could withstand such extreme environments. It's all very theoretical. And though it seems like science fiction, lots of notable figures, like astrophysicist Neil deGrasse Tyson, believe this type of life form is possible. It's just difficult to portray it. Number 5. Planets with different stars. Not all stars are like our own, and planets surrounding different types could be host to very different types of life. Our sun emits light at a peak wavelength of around 500 nanometers, and this has directly impacted the vision of life on Earth, with everything seeing light at the same frequency. Aliens that have evolved on planets around a small red star, like the potentially habitable TRAPPIST-1d for example, would have a wildly different visual range, perhaps only even seeing in the infrared range. They may look like this, with larger eyes to increase their chance of seeing light, and a red skin color to allow them to be seen by others. In these solar systems, the stars aren't as bright either, so life here would be far more sensitive to whatever light there is. Another factor influenced by this type of star is the amount of radiation the planet is exposed to. Next to a smaller red star, organisms will need much higher levels of protection against radiation than we need on Earth, so would likely have very thick outer shells to protect their vital organs. Number 4. Within a brown dwarf. Brown dwarfs are objects in space that are between large planets and stars in size. They are seen as failed stars, ones that didn't attract enough mass in the first place to ignite. This creates atmospheres that are both the right amount of temperature for life, as we know it, and also full of hydrogen, carbon, and oxygen, 3 crucial substances for life. So could life exist in these atmospheres? Or maybe even in the atmospheres of soupy giant gas plants like Jupiter? Researchers generally agree that it's completely possible for microbial life to exist here, as they're the ones most likely to survive an environment of mainly hydrogen gas. If the winds are favorable though, it's also quite possible that larger life forms exist here too, using the air currents to blow them between pockets of nutrients. Perhaps there could be huge creatures as big as whales flying through liquid soupy atmospheres. Number 3. Cold planets. We know from our own planet that life needs a certain amount of warmth to thrive. But would it be possible for organisms to develop on extremely cold planets? The closest place that fits the bill, which is also a place that researchers are keenly exploring, is Europa, one of the moons of Jupiter. It's slightly smaller than Earth's moon and is covered in a crust of water ice, with an atmosphere made up of mainly oxygen. At the moon's equator, temperatures rarely rise above -260 degrees Fahrenheit, but the interesting thing is that plumes of water vapor have been detected coming from its surface. This, combined with the fact that Europa is the smoothest known object in space, suggests that the icy covering of the moon is constantly moving and refreezing, a telltale sign that there's liquid beneath. It's quite possible that this is the case on a number of frozen worlds, but could life exist beneath the 15-mile thick ice sheet? To answer this, we only need to look at the extremes at which life survives on our own planet, with countless species being found in what seems like the most inhospitable places. Hydrothermal vents at the bottom of our oceans, for example, sustain a wealth of microbial life, as well as hundreds of shrimps piled on top of one another. This could well be similar to what's happening on planets like Europa. Number 2. Water planets. Of the thousands of exoplanets that have been discovered, many lie within the so-called Goldilocks zone of their star systems that would, in theory, allow them to support life. And it's thought that many of these could be completely covered in water. Originally, it was thought that the environments of water planets would be rather hostile to supporting life, because some of the gas cycling processes that take place here on Earth would be impossible there. Recent studies, however, have suggested that this isn't the case, and if there had been a lot of water throughout the planet's life, along with an abundance of carbon, then the planet could be stable enough to support life. What this life would look like is an unknown, but the theory of evolutionary convergence would, again, suggest that ocean life on these planets would probably share traits with the ocean creatures we see on Earth. Big flippers to allow the easy movement through the water, methods beyond sight alone that would help to hunt prey, and even bioluminescence to help illuminate the dark depths. Number 1. Dry planets. Life as we know it could not exist on Earth without the presence of water. It's a fundamental substance for all life here, down to the makeup of each individual cell. But does that mean that a dry planet would be unable to sustain life? Studies have suggested that there's an alternative to water that could allow species to thrive: carbon dioxide. On some planet, rather than existing solely as a gas, carbon dioxide can be supercritical, which means that when liquids and gases exist in the right conditions in terms of temperature and pressure, they exhibit features of both gas and liquid. Carbon dioxide does this at 89.6 degrees Fahrenheit, and with a pressure 73 times that at sea level on Earth, something that is completely feasible on other planets. Earthbound bacteria have been subjected to environments made of supercritical carbon dioxide, and have survived for long periods of time. This would suggest that bacterial life forms could potentially develop in such scenarios, and who knows how large they could develop to be. The truth is that life could exist anywhere out there, and it's unlikely to be anything that we could possibly conceive. So, do you think these predictions of alien life forms are accurate? Or do you believe aliens would look for a stranger? Let me know in the comments down below. Also, on the subject of space, did you know we're launching $1.5 billion into the sun? It's fascinating. So go watch the video my friends at Question King made about it by clicking the video on screen now. Thanks for watching.